One other important note to highlight here, and that's again talking about causation or our correlation, right? So the reasons for correlation. Notice the graph that I have here. We have the number of storks as our explanatory variable and our human population as the response. If we are looking at this, we might see that it's kind of squirrely up here, but I might be able to say that there is some sort of a positive linear relation between storks and population. Now, this is an increase in population, meaning more babies are born. So if we read this and interpret just the graph, we would say as the number of storks are increasing, the population is also increasing. Well, just be aware that you can make a graph, a scatter plot, and possibly even a linear scatter plot with just about any two variables that you happen to put together. That's a possibility, I should say. Does that mean, however, that storks cause human population to grow? So hopefully you're saying, no, that's not the case unless you want to go back and retake a biology class. There is an association possibly between the number of storks and an increase in population, but that doesn't mean that storks increasing cause more babies being born. In fact, it was a reverse case. This data was actually collected, and what it really was showing, because they switched the stork and human population variables, they found that the human population was the explanatory variable, so down here along the x-axis, and the number of storks, the response variable, and it was a positive correlation, but the reason was because the storks were nesting on the housing on the chimneys. So this increase in population actually had an increase in nesting sites. All of that's to say, just remember that when we're looking at these observational studies and trying to determine some sort of relationship between our variables, we talk about association and not causation. Association would be those things for observational studies, and causation is going to be for experimental design. Also, as you can see in this last part right here, we might have a causation that happened in reverse. In other words, we have the x and the y axes here, or variables we're determining as x and y switched. And then, as seen in the previous example, watch out for those lurking variables, because lurking variables in a study can also impact your and confound the results of your study.